Hello friends, today we will talk about Python data types and operators. An identifier in Python is a name used to identify a variable, function, class or module. Any type of object. The name of a variable or function or class is an identifier. Naming convention for the identifiers or variables or functions or classes is like this. As a first character, we must use either underscore or a alphabetic letter A, B, C, D at the first character of the name. And after that, I can use any number or letters or digits for the name. This is the first rule, using only letters or underscore as the first character and afterwards any number, letters or digits. A digit cannot be used as a first character of the name. Reserved keywords cannot be used like if, else, for, while. I will show you later what are the reserved keywords. Special symbols like hash, dollar, @ and %, this cannot be used in the name of a variable or identifier. Valid names are like here underscore kind 2. You see here number 2 is used at the last. It may be used in the between also, but not at the first character. Here you see kind underscore man, kind 2 man, like these things. But invalid names are 1 underscore kind because 1 is a number and it's not valid. Also the special character dollar is used here. This is not valid. Identifiers are case sensitive. Capital kind is different than a small kind. It treats two variable names with different cases, different variables. Any variable name starting with underscore x, single underscore x. Any variable name or function name or any class name cannot be imported by from module. We cannot use by importing them. And the variable names starting with double underscores and ending with double underscore are special names, system defined names. Only system uses them. We cannot change them or make our own. These are system defined, starting and ending with double underscores. Variable names with double underscore only, not at the end, are localized and used in enclosing classes. We will talk about this later. Any variable can be assigned any value. Like here x is equal to 0, same x can be assigned as a string hello, same x can be assigned as an list. The keywords used in the Python cannot be used as variable names. The keywords are like this Boolean keywords, true, false, and none. None means empty and no value. This logical and or not, these are operator keywords. Control statement keywords like if, else, looping keywords like for, while, break, continue, like this. Function and class definition keywords like diff, class, return, import, try, use for exception handling. These are not to be used as variable names. Here we defined a list having two elements 1 and 2. If I call append function on this list, L dot append, and passing 3, actually we want to add 3 to the list. It adds a number 3 and the list becomes 1, 2, 3. But this append function does not return a value. If I append value here like L dot append 4, want to append 4 value, and if assign this expression a L value, then L will be none because the append function returns none value. So our list will be lost. We have to keep this in mind. We cannot use like this because append function returns none value and the list becomes none. Data types in Python use are numbers like this integer 1, 2, 3, 4, this float kind of thing, decimal, this complex number. This is a binary number. We recognize binary number in the starting. We use 0 B for binary, and after that we can use only 1 or 0. These are strings enclosed within single or double quotes like Mohan's, like this. These are bits data starting with bits used in image files or audio video files. The important data structures in Python are lists, dictionary, and tuples. List may be enclosed, means a list can contain or can nest other lists or any data structures also. Within a list, I also can store dictionary or tuples. Here in this is a list, and that list contains this smaller list having 2 elements. So a list can contain another list also, that is called nested list. A list can also be created using the list function. First I use range 10 function. It generates numbers from 0 to 9, and that numbers we want to store as a list. Then I make that a list by calling the list function, passing this range 10. Dictionary are data structures that are built by using key and value pairs. This is a dictionary having 2 key value pairs or 2 items separated by comma. First key value pair is food colon bread, means food is the key. This food is the key and its value is bread, separated by colon here. So this is the first item of the dictionary. Second item is started after this comma. The second key value pair is taste and sweet. Taste is key and its value is sweet. So likewise we initialize dictionaries. Dictionary can also be created using the dict function, like here. Calling dict function, passing hours is equal to 10. In this case, hours becomes key and its value becomes 10. This will create a single dictionary with hours as a key and value as 10. Another data structure is like this here, a tuple. Tuple is recognized by having small brackets and items separated with comma here. There are 4 elements. First is an integer. This is a string. Test again is an integer. This is a character. So tuple can also contain different type of elements. A tuple can be created like this also, calling tuple function, passing this string test as a parameter. It will create a tuple having 4 elements. The elements are the characters of this string test. The sets are data structures which can only contain unique value. Any element cannot be duplicated in a set. And sets use curly braces, means elements are enclosed by curly braces. Here this set contains three elements, three character type elements. This is A, this is B, and C. Set can also be created by calling set function and passing this string. This ABC string is a sequence of character A, B, and C, and that is converted to a set like here. So these are four: list, dictionary, tuple, and sets are four important data structures used in Python. We will talk about this data structure later in detail. Booleans are data types they contain only two values, either true or false. None is also a data. It means if any data value is none, means no value. Value does not exist. It is an empty, a name for empty value. File type data are produced when we create a file. Means we call a open function, and in that function we pass name of the file. Here I want to open a file, my file.txt. So enclose file's name within single or double quotes and pass this as a parameter to the open function. This will return an file object. We can read that object using Python. Here I also open a binary file. You see here like this the name of the which we pass here for the file name starts with R, means raw data. Whenever you use this backslash or colon kind of things in a name of directory or file, programmatically we use R, and then the name of that file or directory is enclosed with single or double quotes here. To denote that this forward slash are to be used exactly as it is, because in different operating systems it will be treated differently. And here I pass as a first parameter name of the file, and the second parameter is the what things I can do with the file. I pass WB, means W for I can write in the file, and B for indicating this is a binary file, means this is a file, multimedia kind of file, audio video kind of file containing bitwise data. We will talk about files in later lectures. Another the data types in Python are like integers. You already know, like this integers, floating point numbers 4.27, 1 point, this kind, this scientific notation, and octal or hex. Octal numbers started by 00, this one 0O, and this is the octal number. Hex number started with 0x, and this is the hex number. Binary literals start with binary number 0B, and after the binary this 10 digits we write. So the complex number start we use like 2 plus 3j. 2 is the real part, 3 is the imaginary part. We combine 2 plus 3j as a complex number. These are decimal and fraction functions to create functions, and decimal we will see later. Any data we can convert in the Boolean form, like true or false, by using the bool function. If x is a data, any integer, string, any kind of data, and if we pass bool if we call bool function on that data, it will create a true or false value depending upon what is the value of x. Decimal data can also be wrapped as a decimal class in Python. For this, we need to import decimal module. In that module, we call decimal function. So decimal. Actually, we call here this decimal function of this decimal module by using this dot operator and passing 3.141 within this single quotes. This converts this 3.141 data to a decimal kind of object here. If I append this data d plus 1, it will add the value 1 to this 3.141 and result will be 4.141, but it will be a decimal object, not pure decimal. To print pure decimal, we have to print this decimal object. Likewise, you can divide two decimal values like here. We convert 1 in the decimal form, then we convert 5 as a decimal form, and we divide by using this expression. It returns a 0.2, a decimal object. 1 is divided by 5, 0.2 is returned, and that 0.2 is converted into a decimal object. Like here, two decimals are added, resulting in a decimal object, 0.2 value. Likely, we use fractions here. To convert 1 by 3 as a fraction object, we call fraction function and pass 1, 3. It will convert 1 by 3 into a fraction object and assign its value to x. Then here we convert 4 by 6 as a fraction object assigned to y. If I print x and y, it will print fraction objects, not 1 by 3 or 2 by 3. To print their value, we just call print function, pass that fraction object. Print y here prints the actual value of 2 by 3. So this may use these fractions of objects. Typecasting is a method in which we change one type of variable to another type of variable. Here, if I want to convert 3.1415 value to integer, we just call int function and pass that value in that function. It will convert 3.141 into an integer form 3. Likewise, here we convert 3 to a float value by calling float function, passing the 3, integer 3. It will result in a float value 3.0. Integer value 64 is converted to hex value by calling hex function, passing 64 as value. It will result in this value. This is identified as hex value because initial two characters are 0x and this 40 is the value of the hex. Hex value of 0x40 is equivalent to 64 integer. Likely to convert 64 in 1010 format, we call bin function, passing 64, it will result in 0. This 0b at the starting denotes that this is a binary number, and this 10, this is the value. To detect type of any object, we call type function. Like here, a list is initialized here by 4 values, 1, 2, 3, 4. And if I call type function passing this list L, it will print class list because it is of type list. To check whether any object is of any type, like to check if this list L is of list type, we can call this each instance function. Each instance function checks the type of this first parameter. Here it is L, that is a list, and second parameter to each instance is a type which we want to check for. It is a list type. Since this our list L is a list type, so it returns true. Each instance L comma list returns true because list L is a of type list. True means this if expressions become false becomes true, hence it prints yes. In Python, if we write like a is equal to 3, it means first memory for 3 value 3 is created, and that memory is assigned to a new name A. So A name possesses the address of 3, or we can say A references 3. We can assign any value to any variable, like previously A was 3, now I can assign A is equal to spam here. In this case, string spam will be stored in a memory location, and the address of that memory location will be referenced by this name A. In this case, A will point to 1.23. If we use expression like A is equal to 3, the memory location of 3 will be assigned to A. And if we use B is equal to A, means the new name B will be created, and that will reference the same address which A references. In this photograph we see here value 3 is stored in a memory location, and A is equal to 3 means that A name references that location of 3, and if we assign B is equal to A, means another name B references the same address of the 3. So A and B reference the same location. In a case of object like list, see an example here. Here L1 is equal to 2, 3, 4 means a list named L1 is created with 3 elements. If I use L2 is equal to L1, it means a second name L2 will be created that will point to the same address of L1, means L1 and L2 refer the same address. If I change L1 by using L1 0, means element at 0 index of the list L1. If I assign it value at 24, means this 2 value will be 24 in L1. I print L1, it will print 24. 3 and 4 are not changed, but at its 0 index, this 2 value will be changed to 24. This change will also appear in this L2 because L1 and L2 reference the same address. Now I come to the one more important topic of Python, that is slicing. For any list or any item of a sequence, indexing is used to access an element, and slicing is used to take away some elements from that data structure, list or any data structure. Suppose X is an any object, any list or any object at then to access its element at ith index, we use notation X, then within square brackets I. This will extract element at ith index of this list X. It may be list or any sequence like structure, like string also or tuple also. Here X minus I. Indexing minus I means last element. Like -1 is the last element. -2 element is the one before the last. So backward indexing starts from -1 and we go leftwise like -1, then -2, -3. Forward indexing starts with 0. I is equal to 0 means first element. I is equal to 1 means second element, like this. Slicing we use here, like if I use name of the list and use here I colon j colon k. Now I is used for starting index, that by default starts with 0. By default value of I is 0 if we don't provide. After the first column value is j. J means we access element up to j minus 1. Suppose if value of j is 4, then its last element of the slice will be 4 minus 1 means 3. And k is for step size. If we want to not continuously read all the data, but after some gap, like after 1 step, after 2 step, then we use this value k after the second column. If I only provide first column, one column, like we use I colon j, it means start at I index and go up to j minus 1 index and extract all elements. But if I provide second column also and here give some value, it means we select data after some step size of 1 or 2. So this syntax is slicing. Extract elements starting from ith index up to index j minus 1 with step size k. We will see some examples. Like we start here, str is equal to dham. Dham enclosed within double quotation is a string. D will be at index 0, H will be at index 1. Likewise. Now, str0 means the first element. Here, that is D. str minus 2 means actually last element is stored at -1 index. And last but 1, this -2 means A. So this tuple str0 comma str minus 2 becomes like D and A tuple. Here str1 colon 3, we don't provide here step size. This is slicing. We start at index 1 and go up to index 3 minus 1 and means 2, means start with 1 and go up to 2, means 1 and 2. So at index 1 and 2 are H and A. So this HA is printed here. Right here, see str1 colon, then this is blank. Means before colon is starting index, that is 1. And after colon, if there is no any number, it means all the items. It means start at index 1 and show all the items afterwards. Means it will show HAM. H is at index 1 and after 1 there are AM, so HAM. Here you see str, then before colon is nothing, means start with 0 index, start with first item, and this one is step size -1. So this means minus one means last element, -1 -2. We deduct 1 from the number after the first column. First column, after the first column value is here -1. We deduct -1 from -1. It is equal to -2. So in this syntax, we start with 0 because there is no value for starting index. Start with 0 and go up to -2 index. Start with 0 means D and go up to -2 index. -2 index, M is at -1 and A is at -2 index. So DHA is returned here, like here, DHA. And this kind of syntax we have to take it carefully. Suppose this string is like this, having many elements. I print here str1 colon 10 colon 2. It means start with index 1, go up to index 10 minus 1 means 9. Start with 1, go up to 9 and with 2 step size means leaving one element here. At one index is B here, and we have to skip 1 means after B it will be this D, after will be F, then G will be not taken, H, then this here last digit it is J. Actually we have to go up to 9th index only here. If we write like the str, then using 2 columns, starting index 0, ending index no value, and the step size is 2 means we have to skip one element. By default step size is 1, but if we provide 2 means skip alternate element starting with 0, and so it prints A, then C. B is skipped. After printing C, D is skipped. So result is like this. If I in this string we see this is hello is a string because it is enclosed with double quotes, and if I provide this square bracket and this slicing here using double columns, the last value -1 means we have to go from the in reverse direction. You see here starting index 0 and ending index is no value, and this -1 means in reverse direction, right to left. So this ole, this is printed. Likewise we can go any these are some examples of slicing, and these are very popular and used in Python language. Now I end this session. In next session we will talk about other part of Python data and operators. Thank you.